Today we're going to be talking about all about circuits. Now you might be wondering why I'm in the middle of a stream. Good question, I will tell you. It's very simple. The reason is because circuits are very much like the water cycle. See, in the water cycle we have the evaporation, we have the condensation, it goes up, it goes down, it goes round and around and around and around. And that, my friends, is what a circuit is. A circuit starts with, you have electricity, you have electrons, and what electrons do is that they go from the negative terminal of your battery or your power source, whatever it is, and they go all the way around. They go through the wires, and they go through your load, whatever that may be, and it goes all the way to the positive side. And then it keeps going and going and going until there's nothing left there. So what that does mean is slightly different from the water cycle, because in the case of the water cycle itself, it replenishes where it comes from, whereas in the case of electricity, you can eventually run out of electrons in your battery. Now, there's other cases that isn't the case, but we're going to get to that much later, probably when we talk about alternating current and Nikola Tesla, but not the car, the inventor. Stay tuned, you'll learn things. Anyway, but today is all about circuitry, and there are 5 different types of circuits, and we're going to talk about 3 of them today. So the 5 are, ready? Here we go. We have open circuit, closed circuit, short circuit, series circuit, and parallel circuit. And let's talk about the first 3 today. The first 3 consist of simply like this. They are open circuit. It's not really a circuit. An open circuit is when you have a battery, you got some wires, but they're not connected to the load, or it's not fully a circle. It's like a circle with a bit missing, and in which case it's open, and therefore nothing will flow. There will be no flow of electrons, nothing will happen. The second one, which is the one we're going to build, we're actually going to build an open circuit as we get to building a closed circuit, but a closed circuit is simply when you have a full circle. You have the battery, you have the wires, you got the load, you got another wire, it goes all the way back to the battery. And in that case, electrons will flow. If there's a way to get home, the electrons will leave the battery. If there's no way to get home, stay in shut. Now, the next one is a very dangerous one, and that is one not one we're going to make. This is the case of a short circuit. And a short circuit is where there is nothing being done with that electricity. Short circuit is the case where you have a battery, you got wires, and they do not go through anything. There's no motor, there's no light bulb, there's nothing happening. In which case, the only thing the electricity does by going through this thing is generate heat. And so if you just put this straight back into the battery, you just generate a ton of heat, and eventually you're going to blow up your battery. It's very dangerous for you if you say you're holding it and saying, why is this thing getting hot? And yes. So, just as a general rule, if you find electronics that are overheating heavily, turn them off. I'm not sure if you guys are up on the latest news, or this isn't even the latest news, this was quite a while ago. Remember when there was the Samsung tablet, or Galaxy, the Galaxy Note 7, I think, kept blowing up? Or when you had the hoverboards made by rip-off companies that kept blowing up? That was because something in there short-circuited, right? And what happened was that everything just eventually it just built up heat. It wasn't doing anything besides heating itself up, and then it caught fire. And when the lithium batteries catch fire, it can burn for days and days and days. It's extremely hard to put out, and it can be highly explosive. Now, in your case, you're probably not using a lithium battery, unless you are, but in your case, you're probably using an alkaline battery, and what an alkaline battery is, we're going to get very much more into batteries later on. We're actually going to build them ourselves, but for your purposes, just for the safety purposes, your alkaline batteries won't catch fire necessarily, but what they will do is to heat up to the point that they will burst and spray all of the liquid inside it everywhere. Now, battery acid is very, very dangerous. If your batteries are not new, check to make sure they're not leaking, because if that gets on your skin, that can cause all kinds of skin burns. Not the fire kind of burn, more the chemical kind of burn. So do not use it if it's leaking. Also, probably won't have any charge, but side issue. And if it starts heating up, disconnect it. So a couple of safety things, a couple of circuitry things. Let's head over to another location, and we're going to build our very own circuits for the very first time. Let's go. Hello everyone, and welcome to my dining room. I think last time we were here we were making a rain gauge, and I noticed a problem with that particular setup, and that was like this. You could not really see what I was doing. So, to remedy this, look what we've done. Yes indeed, you can see As you can see my hands because we have a camera up, we have a camera facing my face, we have a light here, we have the window, it's very bright, it's very airy, you can actually see what is happening, it's amazing. So, today and right now we will be learning how to make a circuit, learning what a circuit is, and how to make one. So, you're going to need a couple of materials from your material bag that I gave you, and a couple of things from home. So, number one, you're going to need a power source, AA batteries, 2 of them. There you go. You're going to need your load. We call it a load. This is the thing that uses the power, which is the light bulb right here, and the light bulb holder for your convenience. We're going to need some wires to connect them. Use your alligator clips. They're very convenient. And we need some Scotch tape. So let's start assembling things. So now we have a problem here because this, as I mentioned previously, is a 3-volt light bulb. And the issue with these is that each of these are only 1.5-volt batteries. So we need to combine them to make one super battery that can power this light bulb. So what we're going to do right now is we're going to take them, we're going to hold them like this, and ta-dam! Now, if you run a wire from these ends to that battery, you're channeling 3 volts. But here's the problem, you don't want to hold it, so here's where we're going to take a piece of tape, and we are going to join them. Make sure they're touching. They don't have to be smushed against each other. It doesn't matter once they're touching. They are good to go. Just stick that right there and wrap it around. Good. Good. Beautiful. Now you have one super battery. Excellent. And now we're also going to assemble our light bulb into our light bulb holder. Doesn't have to be all the way screwed in, just enough that it's touching the bottom plate. So we have our light bulb, we have our load that uses electricity, we have our power source that provides electricity. Now we need to join them to make a circuit. So then, in fact, there are 5 different types of circuits, and we're going to start building, and I'm going to let you know when we get to type number 1. So let's clip one end onto here, and leave that right there. One end onto here, and see, on the positive end, you can actually get the claw, the mouth of this, to bite onto there, just to stays. Excellent. And right now, if you're up to where I'm up to, which you should be, so I'm going to give a moment to everyone to catch up. Right now, you should be up to the point where you will now have an open circuit. An open circuit is a circuit that's just not quite closed, hence the term open. And there's no electricity going around, it's not powering anything, no electricity is leaving the battery, none of it's coming back, nothing's happening. This is a very safe circuit because nothing's going on. So now we're about to close the circuit. Here we go. So you can take the loose end and attach it to your Alright, so as you can see now, the circuit is closed. Now the light bulb is on, and there you go. There you have it. That is a closed circuit. So, as you may have noticed, I did not end in the same position that I started, and that's because things went wrong. Now, in all physics, and specifically in electronics in general, circuitry, very many things go wrong very quickly, and one of the most common things that goes wrong is that you're simply not connected to the things you thought you were connected to. So in this case, my battery pack, the inside of here, the bits were not touching. And so it was not conducting any electricity. And so I had to then rewrap it for it to now function. Here we go. There you go. Now it's functioning. All right. Whoop. Now it's on. Now it burns very brightly, in fact, because now you have 3 volts going into there. So if things do not go as planned, just check your connections. But let's get back to what we're talking about now, and that is a closed circuit. Closed circuit is simply a circuit that is in fact conducting electricity. Simple, has one power source, it has one load. It is a classic circle. So tomorrow we're talking about how you can attach more than one load to your circuit into your one power source. And there's 2 ways you can do that. That ends up being circuits number 3 and 4. We're going to just talk about really quick what circuit number 5 is, and is one you should never do intentionally, but can happen by mistake. And that's simply if you remove the load, which I had taped down because it's easier that way. If you remove your load and you just have your battery and you attach it to itself, okay? That's called a short circuit, and it's very dangerous. Do not do that, because what that does is it simply causes electricity to flow without anything lessening it, without anything using it, and that just generates heat. If you generate enough heat in one of these batteries, it can blow up. So, lesson of the day, do not make a short circuit. And open circuit is one that is not doing anything. It's open. A closed circuit is one that is closed, that is in fact makes a full circle, and electricity is in fact flowing. So we will see you all tomorrow. Have a great day.